In statistics, we often think about how two variables are linked. For instance, in the topic of probability, we look at mutually exclusive and independent events, showing how the outcome of one event can have an effect on another. Correlation describes how two events are linked. For example, if older music in a record store tends to cost more money, then there is a link between the age of the music and the price of the album. Plotting this on a graph, we would see this line. From the graph, it can be seen that the price of the album increases with its age. We can therefore say that there is a positive correlation between these two variables. A negative correlation will be represented by a line with a negative gradient, such as this line. It is important to remember that whilst there may be a correlation between two values, this does not necessarily mean the two values are actually linked, causally. For example, in the 20th century there was shown to be a strong correlation between eating ice cream and contracting polio among children, although eating ice cream actually had no such effect. One measure of the correlation between two values is the product-moment correlation coefficient, represented by the letter R. This ranges from -1 to +1. The closer the value of R is to +1, the stronger the positive correlation, and the closer it is to -1, the stronger the negative correlation. These are the formula you will need in order to calculate the product-moment correlation coefficient. SXX, SYY, and SXY are just formulae we have created so that it is easier to calculate other means of measures in this topic and other topics, for example, the regression line. You will not be required to derive these formulae in S1. Let's go through an example so that you can understand how to calculate and interpret the product-moment correlation coefficient. Let's talk about the number of fish in different temperatures of water. First, we need to calculate STT. We can do this by using the formula and inputting the data. We can then calculate SFF and STF. Now that we have these values, we can use the formula for the product-moment correlation coefficient. In an exam question, you might be asked to interpret the value of R, which in this case is 0.9495 or 0.950 to 3 significant figures. This means that there is a very strong positive correlation between the two values, and therefore the number of fish caught increases with the temperature of the water. Now we will move on to lines of regression. These are essentially highly accurate lines of best fit, and they come in the form y is equal to a plus bx, where b is the gradient and a is the y-intercept. We can calculate a and b using the following formulae. You can see that we need to calculate b in order to calculate a, so let's calculate b first. In an exam question, you might be asked to interpret this value of b, which in this case would show that for every 1 degree increase in temperature, the number of fish that we catch increases by this amount. Now that we have this, let's use the stored value in our calculator to find a. This means that the regression line of f on t is as shown below. Plotting this on a graph, we would see the following line. This matches our value of r, as we can see from the graph that there is a strong positive correlation between the values. The regression line can be used to interpolate and extrapolate information on the data given. Interpolation is the use of the regression line to find information in the range of the data. For example, if we were to estimate the number of fish caught in water at 23 degrees Celsius, this would be interpolation, because it is in the range of 5 degrees to 35 degrees Celsius. However, if we were to estimate the amount of fish caught in water at 42 degrees Celsius, this would be extrapolation, because it is outside the range of the data. This means that interpolation is a more reliable method of estimation, as the data could be vastly different outside the given range. In this example, we might estimate the number of fish in water at 80 degrees Celsius, but this would be highly inaccurate as most of the fish would probably boil and die at this temperature. It is important to remember that this model is only a model, and therefore will not be 100% accurate in its predictions. So to recap, Correlation describes the link between two values. We can talk about negative and positive correlation. And correlation can be measured using the product-moment correlation coefficient, R, which ranges from -1, negative correlation, to +1, strong positive correlation. You can also use the formulae that we've covered here to calculate the equation for the regression line. And the regression line is essentially a highly accurate line of best fit that allows you to estimate data that you don't have and also allows you to see the general relationship between two variables. Thank you for watching.